Okay, students, now let's talk about Rolle's theorem. So here you will be given a certain function, as you see, f of x cubed minus 9x squared plus 24x minus 16 on this particular interval 1 to 4. So if the function f is continuous and differentiable on a given interval, then Rolle's theorem said that there exists a certain constant number within the interval, at least one number, such that the derivative of f at that particular number within the interval can be 0, provided that f at 1 and f at 4 are 0. So let's start our calculation. So the solution now goes like this. Look, we are now here interested to find a certain number c within the interval 1 to 4 students. Within the interval 1 to 4, in between 1 and 4, such that the derivative of this can be 0. Basically, Rolle's theorem is a specific case of mean value theorem, and so as you see, our function f is a polynomial function, which actually is a continuous one. See, actually this theorem must be asserted in a function which actually should be continuous. So the function f is a polynomial and continuous, because we know that polynomial functions are continuous everywhere, and also differentiable within the upper interval 1 to 4. So Rolle's theorem can now be applied. Next, let's check whether f of 1 and f of 4 can make 0 value or not. So as you see, if you substitute 1 in place of x, look, f of 1 is 1 cubed minus 9 plus 24 minus 16, and this makes minus 8 plus 24, 16 minus 16, 0, as you see. And let's substitute 4 again in place of x. f of 4 is going to be 4 cubed minus 9 4 squared plus 24 times 4 minus 16. So this turns to be 64 minus 144 plus 96 minus 16. Again, you will obtain this to be 0. So Rolle's theorem requires f at the extreme values of the interval to be 0. So again, this is attained. Now if it's differentiable in the open interval and continuous on the closed interval, and f at the extreme values, f at the extreme points are 0, so we can apply now Rolle's theorem, saying that there should exist at least one number within c, within the interval 1 to 4, such that the derivative can be 0. So now let's try to calculate this number. Basically, this number is a critical number, students, because it is a very decisive number in order to determine these local extreme values. So let's now calculate this number c within the interval. So f derivative at c for this particular function is 3c squared minus 18c plus 24 equals 0. So from this, 3c squared minus 18c plus 24 equals 0 can come. And from this, the value of c is going to be obtained as you see. 3 into c squared minus 6c plus 8 is equal to 0. We just took 3 as a common out, as you see. So what is left here is c squared minus 6c plus 8 is equal to 0. So try to think of two numbers where their sum can be negative 6 and product 8. So these are minus 4 and minus 2. So as you see, factored as 3c minus 4 into c minus 2 equals 0. So the values of c that makes this 0 are 4 and 2, as you see. But if you take 4 and 2 and try to see, well, you see the interval extends from 1 up to 4, you see, it extends from 1 up to 4. So we are looking for a number within this, you see, in the middle. So number 2 can be taken, you see, number 2 can be taken. So there exists at least one, number 2, you see, lying between 1 and 4, such that this can be attained. So Rolle's theorem holds true. Rolle's theorem can be ensured in such a way. Now comes the other question number 21. It says, find the value of c for which mean value theorem can hold true for the given function f of x is equal to x cubed plus 2x squared minus x minus 1 on the interval minus 1 to 2, students. So again, we have to assure the following conditions. First, Is the function continuous within the given interval? Yes, because the function is a polynomial function, as you see. And also the function is differentiable on the open interval -1 to 2. No problem, because since it's a polynomial one, it can undergo this behavior. Next, now let's try to find f of -1 and f of 2, because the function is defined at -1 and at 2. So let's come to now the solution. The function is a polynomial and continuous within the given closed interval, differentiable on the open interval. So finding f of 2 makes 2 cubed plus 2 times 2 squared minus 2 minus 1, and this makes 8 plus 8 minus 3, which makes 13. And f of -1 is going to be -1 cubed plus 2 times -1 squared minus -1 minus 1. I'm simply substituting -1 in place of x throughout, and I can have 1 here. So as long as the function is satisfying all these assumptions, now there exists at least one number c within the open interval -1 to 2, such that the derivative can be the same as f at 2 minus f at -1 divided by 2 minus -1, but we already have calculated that f at 2 is 13 and f at -1 is 1. So 13 minus 1 divided by 2 minus -1 is 3, and this makes 4. So the derivative of f at c now comes 4. So let's look for now the c in between the interval -1 to 2. So first we have to find the derivative, students, and the derivative of this function turns to be like this. 3 comes down, as you see, so 3c squared plus 2 times 2 is 4c, and the derivative of this is -1. So the derivative of f at c is 3c squared plus 4c minus 1. This needs to be equal to 4. So now the next task is to find the value of c that can satisfy this within the interval -1 to 2. So let's bring this 4 to the left. Turns to be like this. 3c squared plus 4c minus 5 equals 0. So this is a quadratic equation, so we can apply quadratic formula in order to find the solution for this. So this is c equals minus b, which is -4 plus or minus the square root of. So our b is now 16, because the square of 4 is 16, and then -4 times a 3, and -5 follows. Then this needs to be divided by 2 times a, 2 times 3. So what's coming next is c is going to be now equivalent to -4 plus or minus radical 76, because students, this makes -4 times 3 is -12, times -5 is positive 60, and 60 plus 16 makes 76. So this is going to be -4 plus or minus radical 76 divided by 6, because 2 times 3 makes 6. Now here, clearly we don't consider the -1. The reason why we are not going to consider the -1 is because -4 minus radical 76. You know that radical 76 is a number in between 8 and 9, right? Because 8 square makes 64 and 9 square makes 81. So radical 76 is in between, in between 8 and 9. So -4 minus 8 point something like that is going to be -12 point something like that, -12 point something like that, divided by 6 makes -2. So it will be out of the given interval. But if you consider the +1, -4 plus radical 76 makes -4 plus 8 point something, which basically is 3 point something like that, and 3 point something like that divided by 6 is a positive number, which actually is close to 0 point something like that. Clearly 0 point something like that is within the interval -1 to 2, so we can consider the positive one. So if you want, you can use a calculator to determine the real value. Otherwise, just by the analysis I did before, you can directly take the +1, okay? The +1, because the +1 belongs to the given interval, the plus number, the positive result, the +1 belongs to that particular interval. So take c to be -4 plus radical 76 over 6. Basically, I just have calculated that using a calculator, and I obtained that to be 0.79, as I said earlier. And here 0.79 belongs to the interval -1 to 2. So mean value theorem holds true. If the function is continuous within the given open interval, and also differentiable on the given open interval. According to the mean value theorem, there is at least one number in between the given intervals such that the derivative of the function at that number can be the same as f of, you see, the difference of the functional values at the extreme points of the given interval divided by the difference of, you see, the extreme values. So yeah, it is assured here. I hope you have understood.